Motor action. Let's examine the interaction between a conductor that represents a motor armature and a magnetic field that represents a motor's main field. An electrical motor converts electrical energy into mechanical energy. The conversion occurs because of a principle called motor action. Motor action requires two conditions. 1. Current must flow through a wire conductor. And 2. The conductor must be placed in an external magnetic field. Let's look at these two conditions a little closer. Current must flow through a wire conductor. When current flows through a wire, a circular magnetic field forms around the wire. The lines go in a direction described by the left-hand rule. The thumb points in the direction of the electron current flow, and the fingers point in the direction of the circular magnetic flux lines that form around the wire. When current flows in the opposite direction, the left-hand rule shows how the circular field also changes direction. The conductor must be placed in an external magnetic field. When a conductor is placed between two magnets, the wire moves in one direction until it goes outside the magnetic field formed between the magnets. The magnetic flux lines between the magnets are called the main field. The direction of the force that causes the wire to move depends on the direction the current flows through the conductor and the direction of the flux lines between the two magnets. The flux lines of the main field between the two magnetic poles are straight and in a north to south direction. When a conducting wire is located within the main field, the circular flux lines around it become distorted. On one side of the wire, the two fields combine and become concentrated because they go in the same direction. On the other side of the conducting wire, the flux lines of the conductor and the magnetic flux lines of the main field go in opposite directions. The effect is that they cancel each other, making a weak force. The distorted lines of the main field, on the side of the wire that is concentrated, are elastic like a rubber band. As the lines of the main field try to straighten, they exert a force on the conductor's flux lines, causing the wire to be pushed in the direction of the weak side until it moves out of the main field. To help determine the direction that the conductor will move when it is inside the main field, the right-hand rule is used. The index finger on your right hand points in the direction of the flux lines of the main field, north to south. The middle finger points in the direction of the current flowing through the wire. The thumb points in the direction of the force on the wire and the direction the wire moves. Let's test your knowledge. Based on the direction of the electron current flow, which circular arrow indicates the direction of the magnetic flux lines that form around the conductor? The direction follows the electron current flow. In this example, which direction will the conductor move? It will move in the direction of the magnetic field. Congratulations! You have completed this learning object on motor action.